The Jeep Avenger is a small FWD SUV crossover, which we already thoroughly reviewed. Now we're focusing on its consumption and energy efficiency. As this is Jeep's first attempt at an EV, the brand has chosen to test the waters with a new, smaller model before transferring this technology into its well-known, bigger models. The Jeep Avenger sits on the Stellantis small platform, which is shared with other Stellantis models like the Peugeot E2008 and Opel Mokka E. The Avenger looks vastly different from its siblings as it gets more rugged looks and boxier design, whereas the interior is somewhat less fancy. The FWD Avenger comes with 115 kilowatt, 156 horsepower, and a 54 kilowatt hour battery, 51 kilowatt hour usable, which aren't exactly impressive numbers, but they aren't terrible for a vehicle of the size. Below, you can see our real-life data on how it does against some similar vehicles on our test route. 60 kilometers per hour, 90 kilometers per hour, 130 kilometers an hour. As you can see, the little Avenger performs quite well on our test routes, which includes constant driving at constant speeds at the same locations over round trips to negate elevation change and wind effects. Our ambient temperature was a bit high at 26 degrees, but still enabled great endurance. What stops the Avenger from ranking higher is its small battery, which is smaller than most other tested vehicles. So despite its great efficiency, especially at city speeds, the Avenger is among the shorter range cars we've reviewed. Once we move on to the 90 kilometers per hour test, the less than stellar aerodynamics take a toll, and the consumption quickly goes up. At the highest testing speed of 130 kilometers an hour, the consumption is already close to much bigger vehicles. Combined with the smaller battery size, this leads to far from impressive highway range. And we now suggest you use the widget below to find out the Avenger's range in every combination of speed, temperature you might need. We've used our real-world tests in a complex model to provide an estimate that should be as close to the actual performance as possible.